Welcome to my presentation. In this presentation, let us see how to find the angle between two vectors. Let us say if the two vectors are given to us as follows. If u is a vector and if the components of these vectors are 3, 1 and the components of vector v, let me write this a little better. Components of vector v are -2, 4, we want to find the angle theta. We want to find the angle theta between these two vectors. Okay. As a first step, I want to just graph these vectors out, and then we will find the angle theta between these two vectors in just a minute. Okay, so the way to do that is as follows. Let us say we have, this is step number 1. Let me take it a little more on this side so we can represent it a little bit more clearly. So let's say we have some points in here, 1, 2, 3, 4, 5 on the x-axis, and then let us say we have 1, 2, 3, 4, 5 points on the y-axis, and then we'll take some more points on the negative x-axis, 1, 2, 3. Say this is 1, 2, 3, 4, 5. This is -1, -2, -3. This is 1, 2, 3, 4, and 5. Okay, this is the origin, and let us first represent the vector u. Vector u is 3, 1. We'll be going to travel 3 units on the positive x-axis and then go up 1 unit, so that will be the point where that is the terminal point for vector u. So from the origin we're going to draw a straight line, and this is our vector u, and the ordinates for that are 3, 1. The second point, the vector v, is -2, 4. -2, we're going to travel 2 units on the negative x-axis and travel 4 units on the positive y-axis, 1, 2, 3, and 4. So that's our point. So we want to join that by a straight line to the origin. That's the starting point, and this is our vector v. And the ordinates for the terminal point of vector v is -2, 4. -2, 4. What we need to do here is find the angle between these two vectors. We want to find the angle theta between these two vectors, and the way to do that is as follows. We're going to write that as step number 2. We know the angle theta between these two vectors is given by the formula cosine theta is equal to vector u dot vector v divided by, this is vector v, divided by the magnitude of vector u times the magnitude of vector v, like that. Okay, so u dot v is going to be like this, isn't it? So we can write this as 3, 1, those are the components of vector u, dot the components of vector v are -2, 4. That's the numerator part. In the denominator, the way we can find the magnitude of vector u is by writing it out in this manner. We write the square root symbol, and then we take the first component of the u vector and then raise it to the power of 2, and then second component and raise it to the power of 2. That is the magnitude of vector u. Similarly, the magnitude of vector v is going to be, we take the first component, raise it to the power of 2, take the second component, raise it to the power of 2 under the radical symbol. So now it's just a matter of simplifying these numbers, and when we simplify, it simplifies as follows. That is going to be equal to, that is cosine theta is equal to the way we can simplify u dot v, the way we can do a dot product of these two vectors is as follows, isn't it? 3 times negative 2 plus 3 times negative 2 plus 1 times 4. And then in the denominator we have 3 squared is 9 plus 1 squared is 1. And then the second part is 2 squared is 4 and then 4 squared is 16. So we got the second part as well. So when we simplify this simplifies to negative 6 plus 4. 3 times negative 2 is negative 6, 1 times 4 is 4, and in the denominator we have square root of 10 times square root of 20. Therefore, we can simplify this to negative 6 plus 4 is negative 2 divided by square root of 200. 10 times 20 is 200. So therefore, we can also write this as follows, isn't it? We can write this one as negative 2 divided by, we can write this as 2 times 100. 2 times 100 because 100 is a perfect square, and therefore I can write that as equal to negative 2 divided by 10 square root of 2, like that. Because since 10 is a multiples of 2, I can simplify this some more as 1 divided by 5 square root of 2. 1 divided by 5 square root of 2. So the way we see this is as follows, isn't it? Cosine theta is equal to negative 1 over 5 square root of 2. So since we want to find the value of theta, we're going to find the inverse of cosine. You can find this on your calculators. Cosine inverse negative 1 over 5 square root of 2. We want to find the value of this. So therefore, we want to find the value of cosine inverse of negative 1 over 5 square root of 2. And when you use your scientific calculators, the value is going to come out as equal to 98.13. 98.13 degrees. That is in terms of degrees. Or in terms of radians, the value is going to be equal to 1.7127 radians. We can express the degrees in terms of, we can express the answer in terms of degrees or in terms of radians. So in terms of degrees it is 98.13 degrees, or in terms of radians it is 1.7127. The difference between degrees and radians, we have seen from our trigonometry that it is as follows. If I were to draw two circles, and if this circle represents degrees and if this circle represents radians, if this circle represents radians, the degrees, the way we represent this is as follows: 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to 0 is 360 degrees. In terms of radians, it is going to be 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and then 2 pi radians. So this is the way we want to be able to represent an angle in terms of degrees or in terms of radians. Counterclockwise is always a positive measure. Counterclockwise is always a positive measure. Clockwise is negative measure. So that is one of the things which we have seen in trigonometry, and that is what we will use here. So just to answer the question, the given question, we wanted to find the angle between these two vectors, and the angle between these two vectors is 98.13 degrees, or 1.7127 radians. In my next presentation, we shall look at some more examples related to how to find the angle between two vectors.